Okay, I think we'll get started. So, hello everyone, and thank you for joining us this Saturday for our webinar on best practice for data scientists to protect themselves, their teams, and their customers. Today we have Vance Sullivan joining us, and he will be leading the discussion on this topic. So John is currently a partner at 360 Business Insight, and his work in predictive and prescriptive analytics has spanned over 20 years with a specialized focus on preferred vendor lead time strategies, HR discrimination identification, supply chain optimization, risk mitigation, and nuclear energy human performance and root cause investigations. And his definition of data science is simple. Data science and its variants direct actions to change the probability of people, processes, and products in achieving the desired state. Okay, but before we get started with the topic, I wanted to go over ideas and tell you all a little bit about it and what we stand for. So, a moment. Right. So, IDEAS stands for International Data Engineering and Science Association. We're a nonprofit organization located in California. Our mission is to bridge the gap between academia and industry. And we do that by providing robust resources and connecting real world expertise together from business leaders, professionals, and promising students. We empower and nurture community growth by offering online resources, conferences, latest industry trends, and data-related job opportunities. And here is a roadmap of our journey. So we started out in 2016, and we have organized various events around the nation, from conferences to blockchains, hackathons. We cover topics like data science, machine learning, and we try to bring in leaders from the industry and academia together to guide and empower the next generation of leaders in these areas. Okay, and here's a couple of pictures of our previous events. So here's a 2016 SoCal conference at USC. And then we have our 2018 New York Blockchain Leadership Connect, as well as our 2018 Chicago Blockchain Leadership Connect as well. And then our 2017 SoCal conference at the Pasadena Convention Center. And then this is our SoCal conference of last year. We do have our 2019 SoCal Data Science and AI conference coming up in October. So if you guys want to learn more information about that, you can go onto our website. And then here's some other events that we've had. We've had the Harvard AI Data Science and Blockchain Conference, the Boston Blockchain Fest at MIT. Here's some other events that we've hosted. And then we also like to host mixers and meetups. We host these mixers and meetups across the nations at various universities. And if you would like to learn some more information on ideas, you're more than welcome to visit our website. You can also connect with us via our social media outlets. And if you have any questions in particular, of course, you can always send us an email. And okay, without further ado, now we can move on to the main event of the hour. Mr. John Vance Sullivan, thank you for joining us again, and the floor is all yours.
Great. All right. Thanks, Jasmine. I really appreciate it. And let me, let's see here. I need to, there we go. You're shrinking your screen, and I am bringing my up, and hopefully everybody is kind of, I don't know, maybe kind of not understanding exactly what we're going to do today, but I'll just tell you and start off from this point, even though we're not talking about algorithms and processes and practices and those kind of things, my contention is that I've seen over and over again where, and it can go all the way from just, line of business employees to actually CEOs reveal certain parts of information that can destroy millions of dollars of value, hundreds, if not thousands of hours of work of data science, because they reveal small pieces of the puzzle that lead to great insights of what people are doing. And I'd almost make this akin to a football analogy of being, it's one thing to steal signals. If you ever look on a football field, the guys have all of the flip charts and all those kind of things on the side trying to confuse the opponent of what they're actually doing. But it's quite another thing to acquire or steal the playbook. And my thing is, there's not theft going on in the playbook. It's that people inadvertently do things that are leading to that playbook being totally revealed to their competitors. And maybe it might have a detrimental effect to their suppliers and also to their customers and also their customers' customers. So that's really what I want to talk about today. And if we go into this, it's kind of a puzzle, if you will. And I want to bring up 4 areas that I just want to look at to kind of set the stage, if you will. And they're kind of disconnected a little bit, but I'll back them up by some insights into each one of them. And then I want to go into a real world example of what I thought was, to be perfectly clear, of what I think was one of the major factors in the results of the 2016 election that I don't think anybody else has talked about. So I want to bring that up, and then we'll transition that into a discussion of how just a few, I can't go into everything on what individuals can do, and then what teams can do, and then really what companies can do to protect themselves so that they keep their high prized and top secret intellectual property assets to themselves, and so that they are to continue in the business. Because we know at the end of the day, if everybody learns what everybody else is doing and or can defeat these models, then at the end of the day, all we're talking about is price. And once you get to price, there's always somebody who will do it cheaper than you, and that will live at a lower level than you, or whatever, to be out there from that perspective. So these are key issues that we can get into. So real quick, I want to thank Ideas for having me, but let's just kind of jump right in here for a second. And I want to start out with the first one here, being looking at the birthday problem. And if you don't know the birthday problem, somebody will call it the birthday paradox. And really the question is, how many people do we need in a room so that the probability of 2 of them having the same birth date is 50%? And the issue that most people run into that are non-statisticians or those that are us in data science is that population of people really looks at, I should say sample of people, because it's not the full population, is really looking at linearity, because they view things not as exponential. And if you go through all the different work here, and you can see the equations, and I'm not going to go into all of them, but it really crosses around 50% between 22 and 23 individuals in a room, randomly picked. We know that the number of birthdays throughout a year is not a uniform distribution. There are certain days that have far fewer births than others. And conversely to that, if you keep going up, you can see here on the curve as it rises up, once we get to about 70 people, it crosses into the 99th percentile. And if you get to I guess 90, it's almost 99.9% that we will have the probability that we will have 2 people that have the actual same birthday. And what I want to leave you with in this kind of example right here is that we really want to look at this in reverse. And what I mean by in reverse is that the same thing we see is that there's so few people that actually get to such a big number that we think. A lot of times it just goes in that we only need, like you look at the games where they turn the letters, people try to do things, Vanna White and all that good stuff that she does. You wouldn't even need the vowels, through the computer generation world and all those kind of things that we're looking at. You'd be able to guess it just with a few consonants to actually to solve the puzzle. And that's the reason why, if you look at things like Watson when it was on Jeopardy, was just such a dominating force to be able to to control and actually win those games. So the first thing I'd like you to think about is down here at the bottom. It says with exponents, the situation is always greater or less than we think, because we're linear beings that we do, and we don't have to give away so many clues to understand what's going on. So let's move to item 2 for a moment. And item 2 starts with a game. And so if you will, let's just play a little numbers game here real quick. I'd like you to think of a number between 0 and 10. All right, everybody get your number, think of it, remember it, because you will need it a little bit later. And now I would like you to add that number to itself. So if at 0, you're still at 0. If you're at 10 and you're at 20, and anywhere in between, you can figure that out. All right, so now we're at a new number. And then once you're at that number, I want you to add 8 to it. So if you add 8 to that, that's great. And now once you're at that number, I want you to divide that number by 2. Awesome, you're at that number. And then I'd like you to subtract your original number from that number. All right, so now everybody's got a number in their head of what they have come to. And now I'd like you to change that number to a letter. So obviously from this chart right here, if you're at a 1, now you're in an A. If you're at a 5, you're in an E. If you're at a 9, you're in an I. If you're not up in any of these numbers, because our numbers are too small, so it really stop around 12 that we're looking at here. So I really want you to think about that letter that you're in. You forget about all the numbers from now on. And what I would like you to do is think of a country that begins with that letter. All right, everybody got that? And now I want you to take that original letter and go to the next letter. So if you were to A, go to B. If you were at E, go to F, and you get that point as well. And now that you're on the next letter, I want you to think of an animal that begins with that letter. And now I want you to think of the color of that animal. So in my predictive world of what I think that everybody should be thinking of, I believe that you are thinking about a gray elephant from Denmark. And you might go, wow, how did he do that? Well, not really, because I got to tell you, all the numerical things that we did, and I'm pulling back the curtain to how this was actually done, no matter what number you pick, you always get to the number 4. And so that means that everybody is going to get to the letter D. And so when I asked to think of a country that starts with the letter D, there are only 5 of them. The easiest one to know is Denmark, the Democratic Republic of Congo, and Djibouti, which actually starts with a D, but it sounds like it starts with a J is in there. And then you have Dominica and the Dominican Republic. And so most people do pick Denmark. And then we go to the next letter in the thing, E. The most common, the common animal out there that begins with E is an elephant. And then I say, think of the color, it's going to be gray. And so you may think there's a trick to all this, but everybody gets to that same position almost 90% of the time. Some people who live in the southern U.S. or Central America will certainly go to Dominica and the Dominican Republic. But with choices, what I'd like you to think about here is that we think we're in control, but we may not be in control. And sometimes we may unknowingly arrive at a directed solution. And this happens a lot in what we do. I mean, there's lots of things that we do in retail and CPG and those type of things where you may not realize it, but you are directed from the moment you walk into a store or the moment that you log onto a website. So that plays a really great part into where our decisions can be led. And where I want to think about this is a lot of times we get into a very comfortable situation where people are asking us questions, and those questions can lead to us revealing, again, small pieces of the puzzle that can lead to insight that we really would never give away about what we are doing for either our customers or our clients, or even the team that we're working on. All right, so we've done 2. Let's get to number 3 for a minute, and we'll swing around. And this gentleman here is, I guess, one of the guys I really look up to in the way he actually worked in the world. And back in the 60s, he was an inventor. 1960s, he was an inventor. He was also a professor. If you drive a car, more than likely use his invention, and his invention works best in the rain. So obviously here we're talking about the intermittent windshield wiper, so that it doesn't go at a regular pace all the time when you drive, and it adjusts itself to the amount of rain on the windshield and all those things. So Dr. Kearns actually got the patent for this in 1964. And he actually showed his invention to Ford Motor Company. Ford had been working on this for years and could not figure it out. And his invention was really so simple that, to be honest, Ford went ahead and put it on their cars with no acknowledgement or payment to Dr. Kearns. It's kind of a sad story in one way that Dr. Kearns spent almost the rest of his life going after the automobile manufacturers. And it wasn't just Ford, it was almost everybody else for infringing on his patent. And he finally, if you look at the time from 64 to 78, was the first time he actually won that lawsuit. This was actually portrayed in a movie called Flash of Genius. And I really want to play just a short part of that so you can actually see the courtroom battle where Ford has their engineering expert on the stand, and Dr. Kearns comes back and shows it may not have to be some super whiz new invention that comes out. It can be things that are put together in a certain pattern. So let me swing over here and we will play that. All right, so Dr. Kearns and even the portrayal of him in this movie, this is one of my favorite scenes because it really does show, and I think we as data scientists, we really are inventors if you get right down to it. If we, if you're going out to GitHub and grabbing things or building on the learning of others, it really doesn't expand it, but just using it over, that's one thing. But if we go in there and build different methods and algorithms, we really are inventors here, and we need to make sure that these things are put together. Because if you look at this with Dr. Kearns, I mean, the thing he put together was actually made out of a blender, and he was able to solve this puzzle that nobody else could do. And that's just a really monumental thing, where you can see down here in the bottom where I said number 3, it talks about small creations can have extraordinary impacts. And if I had to put that in animal terms, to a canary, a cat is a monster. It may be not anything to us, but it really shows the magnitude of what we can do and what we can choose. And I want to also kind of back this up with a quick little story about my time years ago when I was in college, and I went to work for a bank, and they had a private wealth department. These are the people who actually go out and they sell the management of assets and money. And they would go in and get clients to come in, prospects, I should say, and they would do a detailed analysis of what their financial holdings were, those kind of things. They'd take all the numbers, they'd ship them off to a firm, and in 2 weeks, this big, large binder would come back, and it had maybe 20 pages of analysis and then maybe another 150 pages of calculations that showed the discounted cash flow potential of various rates over their lifetime and those types of things. At that time, I had seen all this, and I was able to go in and see exactly what they were doing on that all those calculations, and I actually built it in the tools that we had, and went in there and printed it out on a laser printer and grabbed those 100 pages or so, and they're in color and all the rest. And if you don't know, back in the early 90s or so, laser printing and laser paper was not cheap, especially printing in color. Printing that 150 pages, I probably easily spent $100 on that. I walked into the gentleman that hired me, and I can tell you his name was Mike Turner. Mike's he's passed away for years now, but he was really an early mentor to me. I showed that to him, and he said, "How long did it take you to do this?" And it was not very long. It was just a matter of hours. When they shipped that all those numbers off to that company who they hired, they were spending almost $2,500 for that analysis and that report when it came back. Mike immediately took me into his boss to talk about what I had created for them. And we weren't in there for 2 minutes when the office manager came in there, and he was about ready to slice me to pieces for printing out all that amount. I mean, he said, "I can't believe this kid that's come in here and wasted all this money and printed all this paper. He needs to be out of here." And unfortunately, Mike stood up for me because he saw the value of what I created. And after that, and all this got going, they after a period of time, they own many banks all the way across the region. These things were totally replaced. And just to get to a short part of the story here, I only worked over Christmas for them, and so around January 15th, I got paid. That was my my pay for for working in December. But then on February 1, I got another paycheck. And so I got on the phone and I called Mike and I left him a message, and he didn't return my call. And on the next 2 weeks after that, I got another paycheck. And finally I called Mike up and I got through to him, and I said, "Look, you've been overpaying me. We need to correct this or whatever." And he said, "John, when the paychecks stop, that's when they stop. And I don't want to talk to you again about this." That bank and Mike paid me for the next 2 years. And his lesson to me was, just because it's easy for some of us does not mean it's easy for somebody else to do. And this is exactly what Dr. Kearns was doing as well. So we can't go around just giving away our knowledge. I mean, things that we know how to do, we need to protect. And a lot of times we are employed by companies, and it's actually their right to decide one way or another how those things are distributed, because we're doing work for them, and especially in some contractual agreements. It's also in NDAs when we do things for customers and clients. We need to be leading the way in protecting intellectual property assets and these rights. All right. Let's continue to number 4 here for a minute. And number 4 is a really simple one, and we're going to play another quick clip. And this one I really like as well, because I'm always amazed at how cartoons say just extraordinary things about our data science industry and our data science world. So let's go over here and learn from The Incredibles.
I'll give them the most spectacular heroics anyone's ever seen. And when I'm old and I've had my fun, I'll sell my inventions so that everyone can be superheroes. Everyone can be super. And with everyone super, no one will be.
It's amazing what we can learn from cartoons and how they swerve right into the truth sometimes. And this goes right to it as well. Again, it's so easy that if everybody is using the same logic, algorithms, everything, even though the data may be the same, a lot of it is very similar. People don't change over different populations or different samples of populations that we're looking to. And my contention down below is that if everybody knows, then the game becomes just like tic-tac-toe. There's really no winners, no losers. It comes out to be a draw, and it's really kind of a rut, a trench, and a grave, and it's just depth if we get right down to it. So we really need to make sure that we look at that, and because, like I said, certain little things can lead to really great attributes. And one that I'll give you another example on this. I work for a company. I'm not going to give any specific insight here at all, but I worked for a company years ago, and they had a special process in place. And all I did was just do the mathematics part and also the algorithms that yielded the results that they wanted to go after. They had all of the intellectual property. They had thought about it for years, and they did it pretty much manually. But the thing that we see in artificial intelligence is how do we do repetitive things that can really give us quick insight from that availability. I fast forward that years later, and I am working for a customer, and they want to do this exact same thing. And I could have very easily just right away and said, "Oh, sure, I know you're in a different industry. It really doesn't matter. I can tell you exactly what we did for this customer and all the rest." But that's not the case. And I actually went to different parts of their organizations, and I didn't ask them questions like, who's buried in King Tut's tomb, so they could actually guess this thing. But I went with them, and the design thinking route and all those kind of things, and they couldn't come close to figuring out what this other company had done. And at the end of the day, I had to say, I can't solve it. And I think we need to be very conscientious because, you know, that company from many years ago is still in business. That is their total IP. That's what they do. It is not, you know, even though I did the work, I know what they did. I can't talk about it. I shouldn't talk about it. I should never duplicate it because that's what they do, and that's what they have to do. Again, this thing really continues on. It doesn't go from one company to another. I mean, even though we may know these things, there are things that we know that are specific to the company or the client or even the customer that we've actually worked for. All right, let's continue on just a moment. And when we get back to the look here, I really want to tie all these 4 points together. And I want to explore what I would call a real world scenario that we can look at here. And this one is taking us back to a date in 2016 at the election. I'm not looking at anything on the political side or you know, who won, who lost, all that good stuff. I just want to say that I think there are other factors that played into this that I think almost no one is talking about. And those factors deal directly with data science. So just to refresh your memory here, let's go out and play one more quick clip to bring us in.
Mike Murphy, you've been politely listening to all of this. Was surprised to hear Michael Steele in the last conversation, and I see him, I'll raise this with him. They essentially did not get this right. We're covering a story that no one saw coming.
Well, my crystal ball has been shattered into atoms here because I predicted the exact opposite of what happened. But I'm a typical, you know, campaign consultant type that we've been living and dying by data for a long time. And tonight, data kind of died. The exit polls originally were off. The polling beforehand, the most credible polling, was off.
All right, this is good right here. So let's just kind of jump to what I call the battle of the vote. And I want to go back, not 2016, but I want to go back to 2008. And this is an article that talks about how then candidate Obama used social media and the way that he was able to really bolster his image and his likability and his confidence and all the things that we needed to get him elected. And clearly John McCain was just, I would say, outclassed in this completely. And he did not understand the game. I think a lot of that may have to do with his situation in life of where he was and using the different technologies that had come available. But Obama and his team were just exemplary in their efforts, and they were able to win the election of 2008. Fast that to the next term, Obama comes out and uses big data to target certain voters and does some really good things on that level that take it far beyond social media, but actually looking at different regions and votes and all those good things as well. You would think that with Mitt Romney having a business background that he would have been extremely astute as well, especially in the art of data science, data analysis, and those type of things. But, you know, he had an app called Orca. That was his team. So like a killer whale. Obama's team was named Narwhal. You can go back and read on that. And as you can see here, we know the results of that election as well. Even though Romney actually was leading in the polls for a couple of weeks before the general election, the Obama team just really kicked it in gear and made the right plays in the right places to get the right vote out for him to win. And again, it was just another extraordinary effort. Where I kind of say that there may be some things going on, and I may be right, I may be wrong, I may be out in left field, I don't know, but this is what I think is an integral part of what actually happened in 2016. Right after Obama won in 2012, you started seeing articles come out by various people talking about not just the results of the election, but really what they did, who they targeted, how they did it. And, you know, to even get even further into that, there were actually, if you go search online, you can probably find it. I mean, it actually shows examples in code of what they were doing and across the board. And you saw, I mean, you know, firms coming out there saying, yeah, we worked on it, and think tanks that worked on it. You had vendors that said, oh, yeah, it was our technology that made this all happen. and all those kind of things. And it just happened over and over again. And this goes right back to what I was talking about earlier of saying that, looking at signals is one thing on the football field, but giving somebody your playbook. I mean, when you tell me or show me the code, it doesn't take much for me to understand enough for me to beat what you're doing so that I can do things and misdirect you or see different things in data. And that's the way I see where, oh, we don't have to go there. We've got that wrapped up. When in fact, they did need to go there. And these are things that can be easily displayed in mathematics. And I think that's a really good terminology to use. And there's just so many examples of that over and over again in history. So we look at data science a lot from the revelation part of what it can reveal. But it can also be a misdirection type play as well to actually throw people off from that perspective. So again, if we don't go out and tell people what we're doing, it makes it much harder for them to defeat what we're trying to achieve. And like I said, was stated in the introduction that we just had for me, my definition of data science is how do we increase the probability or chance of getting people, processes, and products to do what we want them to do or achieve. It's a very simple definition, and you can see easily how that could be turned around to do what do what somebody else does not want them to do. So we really need to take care in wrapping all these things together. So I may be right, I may be wrong, but that's my view of one of the major contributing factors to the 2016 election. So if we continue on for a moment, I want to stop in for a second and really talk about how can we protect ourselves and our teams and our clients. So when we go into this, it really breaks down into a couple of areas here. And the first one I want to talk about here is how can we protect ourselves? And my background is not in pure mathematics and those types of things. It really deals with, well, I actually started out as a chemist, and then my master's degree was in management science and operational methods and those types of things. And one of the things that the science part of data science that I think many people don't really get into is actually writing down all the things we do to attack the scientific method. So, notes on what you did, the observations and the results, not always just focusing on documenting out the successes that we have. It's the failures that we learn the most from. And even one of the things that's kind of caught my eye recently, if you look at the failure of SpaceX, where their capsule blew up here, and you can see that in 2019. And I remember going back in the past here, there's no Apollo 2 through 6 for the moon missions. Apollo 1 actually had a fire on a test run that actually killed all 3 astronauts on the pad in 1967. So we had 2 capsules that exploded, and it really kind of gets to the point. I would like to see maybe the root cause of both of these, because, well, we know the root cause of what happened in 1967, but do we really, 50 years later, have we learned things or forgotten things that may have contributed to what we see here happening in 2019? So you see here over on the right a kind of a documentation of, hey, this one we didn't get anything out of it, the next one got something out of it. This is actually a chemistry one, but I definitely do this for everything I ever work on with a client. I keep a notebook. I actually have done it in various ways, electronic methods, that kind of things as well, to keep these things, but always documenting out really where I took my mistakes and missteps. And those are invaluable in the point of view of looking at not repeating the same misstep over and over again, or having other people on the team or in other areas having to do things that don't produce any potential to increase that probability of what we want to have happen from there. So when I look further into this, I propose to you, and you can come up with your own kind of confidentiality scale, if you will, and also how we actually identify these assets. And when I look at how do we protect the assets here and accountability, we should hold ourselves accountable. even by speaking out as others are speaking and doing things, to say, you might want to reconsider how you say that, or you shouldn't say that. And that also goes anywhere from experts who are outside of our part, competition, suppliers, competitors, because they really don't, or maybe sometimes unknowingly, reveal these intellectual property assets and trade secrets, price fixing, and anti-competitive strategies. So I have it just broken down into 5 areas here. And those 5 areas here are basically, is this an internal method, an internal algorithm? So did we create both? Did we actually bring up the method we're using and also write the algorithm, or maybe build on somebody else's work as well? Is this an internal method in a public domain algorithm? So maybe we put a method of how we do certain things and we're using R and those types of things. It could be an internal method with an external algorithm. And that could be something we may get from a vendor. You know, SAS has many patented algorithms in its a portfolio that you can only use if you are a SAS customer. And that goes with any of the other vendors as well that are out there. And then I get to things that have been provided to us by vendors as well. Those are their property. You know, that's what we can have, an external method and also an external algorithm. And then finally here, using public methods and public algorithms. Even though you may write those down already, those are things that may have been shared with us on the web, or we've learned through other assets of people coming in that are free to distribute and do. And you can see here just on my little sheet, and I actually do this in my algorithms as well. I actually write down these classes here, and I go further than this too, and actually decide, is this confidential information? Can it be shared in a public A? Do I need to get permission to share it? And or does somebody else have to get permission from me to actually talk about these things? So next we can move a little bit further here into you as well and how to protect in your team here. And I think it's always good to not just think about things from our individual perspective, but how our customers or would actually perceive the work we're doing. So could specific parts of my comments lead to knowledge of our intellectual property assets? So always look at those individual pieces and how they're actually put together. And also always guard against giving examples where an average industry knowledgeable person could actually formulate that data, method, algorithms, or results. We really need to watch what we say, what we do, and who we share it with, and what we need to do. And never, ever give specific results. Like, for example, unit costs were decreased by 30%. This is exactly what happened in the 2016 election we did. They were, people knew implicitly what they were looking at, how they were looking. And if you look at the little picture here that I see, yeah, you might see flowers and a fence that we want to go after here. But yeah, if you ever use stereographs and those kind of things, and you can do it real quick, there's actually a picture of a gardener here and a couple of birds that are being shown here as well. So if you're not good with this, you can probably look at it later and kind of relax your eyes, and hopefully you can see it. All right, the next area is really looking at how you can protect your company and protect the IP assets, again, from that side. And I would say look at this from your value chain, so all the way down from your suppliers to your individual components inside your company, but also your customers as well. And this can be also those people who are in a collaborative effort for you as well. So we need to look at all pieces about that and how our algorithms affect not just us, but them as well. And then finally, again, the comments from a business perspective to specific people. We should not reveal certain people in companies, and maybe we ought to protect them. And, for a time in my career, I actually worked for a software vendor, and I thought it was really interesting. I went into a customer one time, and that customer said they had their data science people, and they did have them there, but they were in another room. They were listening by the phone, and we never got their names or who they are. They actually protected those people tremendously, and were able to really help out in that type of work. So there are really 2 things here I want to show. One, what is a non-disclosure agreement? And that really goes for a lot of different ways. And the example I gave earlier is just to make sure that we don't ever give away intellectual property assets really to anybody. And a lot of times we're asked by internal teams to help them out. And giving it to somebody else within your company, that's just like giving it out to everybody, because they don't understand the ramifications that you may know from a potential client. and they might give it to a lot of other people, and it just hurts everybody involved. The second one over here is really like a paper shredder, if you will, and confidentiality. And this is one that I was actually into personally. And I was actually helping a customer of ours who was giving a presentation. And they went through their whole presentation talking about these things and all the rest. And they made one sentence in there that was kind of interesting. I mean, nobody took it to be much whatsoever. And nobody thought it was anything, you know, out of the ordinary. But after our session was on, I noticed that there were two people that were waiting around until after we finished. All the questions the people afterwards had left, and they walked up. And one of them was actually a customer of this person who was on doing the demonstration, and the other one was somebody who was in the same line of business as well. And they came up and said, "Look, even though that went by really quick and it didn't mean too much, we just need to tell you what you just said, because your data actually pointed to this. This is one of the most top secret things we have going on in our industry for sale to our customers. And we'd appreciate it if you wouldn't ever mention it again." It was one of their, you know, big value propositions that they gave, and it gave insight to it from the supplier perspective to a potential company, well, to two companies that actually use that as a value proposition to their customers. So there are things here that we really need to look at from the ramification. It may not just be us or our company, but it may be our company's suppliers and our company's customers, and maybe our customers' customers from that side. So we really need to take it from that level. So my final kind of position here that I'd like to kind of go into here is what I would call, I don't know, confessions of a data scientist, if that's a good way to actually put it here as I wrap up. And one of the things that I think that may come into our industry, and I wouldn't mind seeing it, but I remember years ago, if I'm outside of technology, all public meetings really used to start the same way. And that is, they talked about the Sherman Act and antitrust and price fixing and all these kind of things being anti-competitive activities, that we can't talk about those things even though we're in the same industry. And you can see the four things here that really make up that act. You know, price fixing, bid rigging, bid suppression, and complementary bidding. And all the things that we do in data science can very easily lead to knowledge of methods that can lead to all of the above, even though we don't mean for them to do. These things that we are so gifted at and practice at can be used in a detrimental way to actually enable these types of activities to occur. And the final one I'll leave you in, this is kind of a statement of contention. And for those of you who may be watching this who are new in data science, you will actually see these actually come up. But I could actually change the we in here to I, and I can promise you as a data science, I have seen insights of data that I should not know. I'm not going to give examples of any of these. Hey, I've seen examples in data from insights that no one should know. And finally, I've seen things in data that I really don't want to know and wish I didn't know to this day. And I've also seen insights in data that we think are small that are really big things in the course of business. And finally, we all see things in data that can be counterproductive or destructive to our companies, our clients, and our customers. And I really believe it's up to us, data scientists, to work with the business so that they fully understand where these things can be exploited, how little we can let people know. Because again, it's right back to Syndro and Mr. Incredible. You know, if I give away everything I got or sell all my inventions when everybody is super, no one is. And that all puts us into a position that we don't want to be in. So at the end of the day, that wraps up my session. I appreciate you listening to me. And this is Ideas. And I'm Vance Sullivan. And I've actually put together something called Robot Mirage that I'm kind of building on top of this as well. If you want to go there and look at some different things that may be that are put together. And my contention is, you hear people always say the robots are coming and, they're going to take us out like Terminator 3 and all that. And I believe that is a mirage. I believe that if we don't get ahead of this and really protect these intellectual assets, we'll end up really shooting ourselves or greatly diminishing our value is our role in data science and its implications in society and business. Hey, I appreciate your time to listen to me. Thanks so much.
All right. Well, thank you, John, for that great presentation. Those who are on, you are all welcome to send in your questions if you have any. You can send them in through the Q&A or the chat box.
I scared everybody off.
I think we have a question via the chat.
Okay.
It says, John, did Olive catch the burglar?
I do not know that.
I did not know that. That's interesting. That question was submitted from Bill Hautinek. My apologies if I'm pronouncing your name incorrectly.
It's all right.
Go give a couple more minutes for
Okay.
other question before we close off the webinar for today. These slides will be shared, right, John?
That is correct.
Yes. So just to these slides will be available, and as well as this webinar will also be available on the YouTube channel of Ideas soon. So for future attendees who didn't get to attend today's session. I think we'll leave it open for one more minute for questions. Everyone's pretty quiet today.
Yeah, and if you have anything in private, you're welcome to email me there at john@360businessinsight.com.
Yes. All right. I think we'll cut it off here. I mean, it doesn't seem like anyone's submitting any questions. Like John mentioned, if you would like to send any questions, comments, or anything in private, you're more than welcome to send him an email. Well, thank you so much again, John, for giving this great presentation with us this evening. We look forward, hopefully, working again in the future with you.
Look forward to it. Thanks again for having me.
All right. Thank you so much, John.